Hi, welcome to the doubt solving session by Brilliant Scholars Academy. I'm Hitesh Hariramani. If you are new to the channel, I'll suggest you pause the video when you see a question, try solving it, and then look for the solution in the method. Let us start. 1, 2, 2, 3, 3, 4 times 4, when divided by 16, what is the remainder? We are supposed to have 120 digits in this particular number. First, let us revise some concepts. What is the divisibility rule for 16? For any number n, if the digits are a, b, c, d, e, and f. Because 16 is 2 to the power 4, I will be looking at the number formed by the last 4 digits, c, d, e, f. So I do not care what is there before c, I only care for the last 4 digits and the number they form. So for 1, 2, 2, 3, 3, 4, 4, 4, I need to find out when will the 120 digits be complete. So look at this. The number is 1. The number of digits is also 1. The number is 2. Digits are 2. The number is 3. I am counting 3 digits. See, I am adding natural numbers to count digits. The number is 4. I am counting 4 digits. This will continue up till 9. When I write 9 times, I am counting 9 digits. So how many digits have I counted so far? This is n into n plus 1 upon 2. I hope you are aware of the formula n into n plus 1 by 2. Here, this gives me 45 digits. Because every number is a single digit number, every digit counts n number of times. But when I count 10, it is 10, 10, 10, 10, 10 times. I'm counting 20 digits. When I count 11, 11, 1, 1, then 1, 1, then 1, 1, I'm counting 22 digits. When I count 12, I'm counting 24 digits. Let us check how many digits have we got. These add up to 66. So far I have got 111 digits. I need to reach 20. Now, because I have counted all the 12s, I'll be starting with 13, 2-digit number, 13, 2-digit number, 2-digit number, 2-digit number. I have got 8 digits. I need one more. So 1. So now if you ask me, I have completed 120 digits. What are the last 4 numbers? 31, 31, 31, 31. These are the last 4 numbers from here till here. So basically I'm supposed to divide 3131 by 16 and get my remainder. 1 times it is 16, 153, 9 times it is 144, 91, 5 times it is 80. So your answer should be 11. The remainder for this entire question is 11. Now, can the right hand side part be done more efficiently? Can you think of a multiple of 16 very close to 32? 31. Yes. If I rewrite this number as 3200 minus 69, I'm not mistaken. This is multiple of 16. The remainder should be minus 69. But negative remainders are not valid. So what multiple of 16 comes to your mind just above this? 16 into 5 is 80. So 80 minus 69 is 11. That is a remainder. So up till this point, you have to find digits and count digits manually. The right hand side, you can apply that trick. Think of the closest multiple. If it was positive 69, I'll look for a multiple below 69. Because it is negative 69, I have to look for a multiple above 69 to make it positive. That is the remainder 11. Let us try another problem. For what value of k will the roots of the following equation be in an AP? So I'm looking for values of roots. I'm looking for a cubic equation and its roots. And roots must be in AP. To be able to solve this question, you should know what does a cubic equation look like when the roots are given. This is how a cubic equation looks like when the roots are A, B, and C. Furthermore, we are being told the roots themselves are in an AP. When 3 terms are in an AP, 5 terms are in an AP, 7 terms are in an AP, we start with a central value. If I say B is the central term, the next term should be B plus common difference, and the previous term should be B minus common difference. So if you know to make this assumption correctly, and if you know the expansion of a cubic equation in form of its root, this question should be easy. We're looking for this term K. This is K. K is equal to AB plus BC plus CA. Now see, when I add this, this and this, I should have the addition of roots, which turns out to be 3B. And 3B, look at this, has a minus sign. Minus 3B is equal to 15. So B must be equal to minus 5. When I multiply these roots, I should have the last term. Look at the sign in front of that. The sign is minus. So here, minus of B into B square minus D square. How did we get this? B minus D into B plus D will turn into B square minus D square. Should be equal to 80. Now B itself is minus 5. If I bring that minus 5 outside, that negative part cancels. So I have 5 into 25 minus D square is equal to 80. Cancelled. 16. 25 minus 16 is equal to 9 is equal to D square. That says common difference can be either plus 3 or the common difference can be minus 3. Let us test both. If the central root is minus 5 and I add the common difference, let us say this is the difference, minus 2. If I subtract, minus 8. If central term is minus 5 and look at this, I am adding minus 3. I am adding minus 3, so minus 8. I am subtracting minus 3, so minus 2. So look at this, in both cases roots do not change. Roots did not change. Now I am looking for A into B. Let us say A into B, 40. B into C, that is 10, and C into A, that should be 16. So the addition of AB, BC, CA, which is equal to K, turns out to be 66. Answer option C. Again, if you are new to the channel, I'll suggest you subscribe to the channel, you like these videos. I'll be live regularly to share these solutions with you. The digits x, y, and z of a 3-digit natural number xyz satisfy the equation 144x 12y plus z is equal to 767. What is the sum of digits of 3-digit natural number xyz in the base 9? The question sounds to be from number systems, and to be precise, within number systems, base systems, number bases. So here I need to understand how do the base systems work. When I say a number is there PQR in a base B, what will that number look like when translated to base of 10? It will look like P into B square Q into B plus R. Once you do this, the number on the right hand side becomes the base 10 number. Do you see something similar playing out in this problem here? Do you see that is 12 square into x? Do you see here 12 into y and z is equal to 767? Understand, 767 is the base 10 value. Once you perform that expansion, the number finally that you get is the base 10 value. So basically xyz is the base 12 value for 767. Once I know what is xyz, then there is one more step. I need to find the sum of xyz in the base of 9. But first, let us try to find x, y, z. Now, what do we do when we want to convert a number to a different base? We start dividing the number by that particular base, divided by 12. So this is 6 times 72, 4 goes in the carry, 47. 3 times it is 36, the remainder is 11. This is the remainder, or we can say it is basically a. Then when I divide this, it is divisible 5 times 60, the remainder is 3, and division is not possible. So here these x, y, z values are 5, 3, 8. That is the base 12 conversion of 767. Now I do not want x, y, z. What I want is sum of the digits of this 3-digit natural number x, y, z in base 9. There's a small flaw in the framing of the question itself. Z is not a digit. Z here is A. What is A? A is 11. So here that's a small flaw in the framing of the question. This was shared with me as a doubt. Here the sum of the digits will turn into 5 plus 3 plus 11. A is 11. The addition would be 19. I'm supposed to convert the sum of these three numbers into base of 9. So 19 divided by 9, 2 times it is 18 carried over 1. Division by 9 is not possible. The remainder is 2. So the number becomes 21. 21. Once it is converted into a different base 9, it will appear as 2, 1. Answer option 3. Let us try more questions. How many factors of number 6912 have exactly 3 or 4 factors? Exactly 3 or 4 factors. So before we start counting factors, if I say 24 is a number, the number is 2 cube into 3. How do we count factors? We increase the power of the prime by 1 and we multiply. That is how we count factors. To be able to count factors, you should be able to factorize the number first. Let us see. Here, when I look at the number 6912, do you see 800 is a multiple of 8 plus 112 is also multiple of 8. So I'm looking at a multiple of 8. The addition of digits 6 plus 1 plus 2 is 9. 9 plus 9 is 18. So what I'm looking at is a multiple of 8 as well as 9. So you don't have to factorize the old-fashioned way. This is obsolete now. Nobody does this. The factorization in this manner, the long division form, is useless now. What you can do is, because the multiple of 8, how many times? This is 8 into 8, 64. 5 is carried over. 8 into 6, 48. 3 is carried over. 4 times of 8 is 32. Now do you see 864 is again a multiple of 8. So I can take out furthermore 8 common. How many times? 108 times. Now we know 108 is 27 into 4. So this is how you factorize numbers slightly faster. This is 27 into 4. So basically 6912 when factorized is equal to 2 to the power 8 into 3 to the power 3. This is the factorized form of the number. Now pay attention. Whenever you want 3 factors, whenever you want 3 factors, 5 factors, 7 factors, 11 factors, 13 factors, what is unique? The number of factors is prime. Please highlight this property somewhere. When you want 3 factors, 5 factors, 7 factors, 11 factors, they're all prime. The only possibility for this is the number to be a square of prime. The number to be prime to the power 4. The number should be prime to the power 6. So when I want 3 factors, I am looking for a number which will be square of a prime. This is divisible by 2 square. It is also divisible by 3 square. So who will offer me 3 factors? 2 square 4, 3 square 9, These are the divisors which will offer me 3 factors. Now, who will offer me 4 factors? To generate 4 factors, one of the possibilities is the number should be prime cube. So do you see it is divisible by 2 cube? It is also divisible by 3 cube. 8 and 27. Another possibility for generating 4 factors is when the number is multiplication of 2 primes, because the power is 1. See, this will be increased by 1, this will be increased by 1 while counting factors. So how many factors will I end up with? 4 factors. So prime 1 into prime 2. Do you see this is divisible by 2 into 3, which happens to be 6. So what did we want? We wanted either 3 factors. So for these two, there are 3 factors, or we wanted 4 factors. For these, there are 4 factors. So how many numbers do we have? 1, 2, 3, 4, and 5. We have 5 such divisors with 3 or 4 factors. At start of every year, merchant increases price of his product by X percentage and offers a discount of X percentage at the time of sale. This leads to a loss of rupees 800. If he increases the price by X by 2 percentage and decreases by X by 2 percentage on the new rate, he gets a final selling price of rupees 19,008. Find the value of X. Before I start solving this, you are supposed to be aware of this. When anything is increased by X percentages and decreased by X percentages, there is always loss of X square upon 100 percentages. Here, it is increasing by X percentage, decreasing by X percentage, and because of this, there has been a loss of 800 rupees. When it increases by X by 2 and decreases by X by 2, you can be sure of this. The percentage change will be X square by 2 square, which is 4 into 100. So as a percentage, if this was a percentage change, this will be a by 4 percentage change. Just keep that in mind. Now let us look at the set of values given to us. I can go into form complex equations and give you the answer. But in such questions, if options are given, think about that. If this is X itself, X by 2 will be 5. X by 2 here for the second will be 10. X by 2 will be 7.5. X by 2 will be 15. Now look at this. The overall change will be X square by 400 the second time and X square by 100 the first time. Let us keep those values in mind. Out of these values, which one seems easiest to work with? You're going to perform X square by 100 and X square by 400 as a division, as a calculation. So do you see this number 10? If X was equal to 10, X square upon 100 would be 1 percentage decline. X was equal to 20. X was equal to 20. My mistake. X was equal to 20. I'm starting with option 2 because X by 2 is easiest to work with. If X was equal to 20, X square by 100 will be 4 percentage decline. If that is 4 percentage decline, when you have X square by 400 percentage, it will be 1% decline. What does this mean? If I think back, if I reverse engineer here, I need a decline of rupees 800. If answer option B is correct, I'm not sure if it is correct. 4% should be 800. 4% should be equal to 800. 1% should be equal to 200. So 100% should be equal to 20,000. See, I'm getting my value very close to 19,000 here. That gives me confidence. I'm on the right path. So if the value originally was 20,000 and I performed a decrease of 800, what do I have? I have 9200 rupees after the first decline. Now, what is the second decline? Second decline is 10% and then increase and decrease. Basically, 10 square upon 100%, which is basically 1%. What exactly is 1%? 1% means removing the last two zeros. So when I subtract 192, I get 19008 precisely. So here everything matches with answer option B. I would not be even bothered about others. I did not check answer option A because 5 square, 25 upon 100 is a decimal percentage change. 7.5 square upon 100 is a decimal change. 15 square upon 100 is a decimal change. Only answer option 2 gave me two integral changes. So I guess this is the end of the 4 or 5 doubts that I received this week. And all the methods I have shared with you are the methods that I personally use in exams. And I pretty much managed to touch 100 percentile in CAT 2022. So you notice I'm trying to be very detailed while trying to solve these questions to explain you. You can customize these methods, these questions to your level and improve on these methods. Happy learning, guys.